So we talked about writing the integral defined function, which takes advantage of integrals undo derivatives, but inverse operations work both ways. So let's talk about how do I undo an integral? So the derivative of an integral defined function. So remember, the integral defined function is an integral from a to x of f of t. I guess I actually should put in there plus, like, plus some value. Some things to note is that constant lower bound and x is in the upper bound. I'm phrasing it that way on purpose because it could be something more than just an x up there. It could be x squared. It could be sine of x. It could be x to the fifth plus 3x squared plus the natural log of x. X just needs to be in the upper bound, constant lower bound. So then when I want to take the derivative of that, the derivative, as long as I have a constant lower bound and x is in the upper bound, the derivative will cancel the integral, and I take my upper bound to replace the dummy variable. So upper bound replaces the dummy variable, leaving me with f of x, and the dt is considered part of the integral, so it's gone. So if I take the derivative of an integral defined function, it leaves me with the integrand with whatever my upper bound was in the dummy variable. So examples of this: if I want the derivative with respect to x of the integral from pi to x of cosine w dw, w is a dummy variable, constant lower bound, x is in the upper bound, so the derivative and integral cancel. X replaces my dummy variable, and there's my derivative. If I need the derivative with respect to x of the integral from 0 to x of 1 over 1 plus n squared dn, constant lower bound, x is in the upper bound, derivative cancels the integral, upper bound replaces my dummy variable, I have 1 over 1 plus x squared. Slightly more complex examples. Notice it's not just an x in the upper bound, I have an x squared and a 7x plus 1, but constant lower bound, x squared is in the upper bound, so the derivative cancels the integral. Upper bound replaces my dummy variable, so I have the cosine of x squared, but x squared itself is a function, so I then need to do the chain rule on x squared. So this is the chain rule on the upper bound, because the integral defined function is a function, x squared is a function inside of that. So composition is involved and the chain rule is needed. So if I look at the second example here, constant lower bound, x is in the upper bound, so derivative cancels the integral. My upper bound replaces the dummy variable. So I have 1 over 3 plus the quantity of 7x plus 1 squared. But 7x plus 1 is itself a function, so times the derivative of that, which is 7. So then what happens if the integral defined function is not set up the way we need? So for example, I'm being asked for the derivative of the integral from x to 5. This is nice, except for one small thing. My bounds are in the wrong spot. But we have a property that allows us to change the order of integration. So this is really asking me to find the derivative with respect to x of the negative integral 5 to x of 3q cosine of q dq. Now I have a constant in the lower bound, x is in the upper bound, so I have the negative sign as a constant multiple. X replaces my dummy variable. And then I could think of it as, well, times the derivative at my upper bound, but that's just 1. And so here is my derivative. Slightly more complicated is if I have x in both my upper and lower bounds. To handle this, whoops, I'm finding the derivative with respect to x. I first use additivity to split this into two integrals. I just need some constant that it is coming between them. I like to use 0, but it doesn't matter. It just needs to be a constant. So 2x to 0 and 0 to x squared. Remember, the integrand does not change when we do additivity. The 0 to x squared is set up the way I need to take the derivative, but I need to do the order of integration on the 2x to 0. So this is the derivative with respect to x of the negative integral of 0 to 2x plus the integral from 0 to x squared. Now I can start going through. So I have my negative sign. The 2x replaces the dummy variable, but then times the derivative of 2x. My plus sign. Derivative cancels the integral, so x squared takes the spot of the dummy variable times the derivative of x squared. And there is my derivative.